Good day and welcome to Numerals in Mathematics 2, Unit 8, which is now the last and final unit for this Numerals in Mathematics 2. Let's look at the outline of the outcomes of learning that we need to know when we are going to go through this unit. The very first thing that we need to know, we need to describe circles and circles terminology. There are various terminologies in circles, and we need to know all these different type of terminologies. We need to classify three-dimensional shapes. We need to know what is a three-dimensional shape, how does it look like, what characteristic does it have, how does it differ from others, for example, two-dimensional and so on. And then we determine the perimeters of a regular and irregular two-dimensional shapes. In other words, we need to know how do we calculate, for example, the perimeters and the distance around the object and so on of an irregular or a two-dimensional shape. For example, if you have a stone, how will you know what is the volume of that stone? Those are the things that we want to hear or to learn how to do it and how to explain it to our learners. And also a two-dimensional shapes, because two-dimensional shapes have three sides, for example, length, breadth, and height, and that means that it's having a capacity, a volume inside there. And you want to calculate or to find out what is the volume of that object. And then we need to calculate the area of squares and rectangles. Those are the things that we're going to discuss. Calculate the length of the side of a square and a rectangle. Calculate the volume of a cubit and cubes. Calculate the unknown dimension of a cubit and cubes. And then you must also be able to discuss and demonstrate method and material to teach these outcomes. In other words, all these outcomes that you see there up, you as a student, you need to explain this to your learner, and you need to find ways and method to explain these activities or these things to your learners. In other words, if you do not know how to get the activities, you will not know how to explain these things to the learner. So you need to prepare in advance to say that these are the activities that I'm going to have in my classroom, where I'm going to teach how to calculate the unknown dimension of a cubit or of a cube. So what do you need to have, for example? If you want to calculate, for example, a volume of irregular shape. Irregular shape means that it doesn't have a volume or a shape. It's like a stone, kind of. So usually what people do is that you look for water, and you have water, and you measure the level of the water, for example, is 25 milliliters, and then you immerse the stone in the water slowly, and then the water will rise. Now the difference between where the water was and where the water is, that's a volume of that object. So those are the things that you need to prepare in advance. For example, when you know that you're going to teach how to measure irregular volume of shapes, you need to have these things already in advance in your class, so that you can prepare or be prepared in advance, so that when the lesson starts, you just demonstrate and show the learners this is how we measure an irregular shape. Good, let's go now into detail. Two-dimensional shapes, for example, a shape that has only two dimensions, such as width and length and height, and no thickness like squares, for example, circles, triangles, etc. Those are two-dimensional shapes. For example, this paper here. This paper is a two-dimensional shape because it's only having this length and that length, and that's all. There's no thickness. It's not. If it was a three-dimensional, it will have another shape there. So this one is a two-dimensional shape. Now, for most children, learning about shape is one of their earliest learning experience when at home or at school. Their preschool years are filled with shape games, puzzles, sorting out toys and stuff. Hence, they come to school with a great deal of background knowledge already. As preschool teacher, it is our job to build upon and extend the knowledge. In other words, you need to know what type of activity, for example, are these learners exposed to. Now they are playing with toys, cars, guns, you know, pen, papers, and stuff like that at home. So you need to build on that, what they know, for you to be able to teach this type of shapes. Now, it is critical for you to explain. And you can take examples of the shapes they are playing with. For example, if there is a toy or a car or a gun, then you can see that it's having a length, breadth, and height. And then you can show them these things, that this one is having length, height, and breadth, and that is, we call that one a two-dimensional or three-dimensional, and so on. So that you can use what they know to come up to the things that they don't know or what you want to teach. Now, their preschool, just as we said that it is filled with toys, you can also ask them to come to bring the toys to school. Those that they are playing with at home, bring it to school, and we're going to learn this and that and that and so on. Now, here I have an example. For example, you want to teach two-dimensional shapes to preschools. You can draw them. When you draw them, for example, the first one there is a triangle. The other one is a square, a circle, a rhombus, trapezium, and so on and so on. Come up to the circle and so on. And then you can ask them to draw or redraw these shapes on a piece of paper. And they will be able to practice how to draw these things. And then you can show them that in the triangled part, there are various triangles. Triangles are not just one type. There are different types of triangle. And then you can show them and teach them that this is how you draw a right-angled triangle. This is how you draw an isosceles triangle, scalene triangle, all those type of triangle. You show them and you draw them. You help them to draw. In other words, you show them on the board and you show them how to draw. For example, what they do, if you want to draw a right-angled triangle, and that's your question that you are telling them. For example, you want to draw a right-angled triangle. First of all, you let them draw a line like that. And then you say, everyone in the class, please draw that line. And then they draw. Now, if you walk around, and you can walk around and go from learner to learner and show them this is what, okay, you are correct, you are correct. And then from there, you tell them to draw. Let me use a different color. You tell them to draw the blue line, for example. Now, that blue line, we are busy now constructing a right-angled triangle. So you draw a blue line and you tell them, all of you draw the blue line, and then you go around and you check whether they draw the blue line. And then at the end, you tell them to draw the green line. And that is your right-angled triangle. Usually they show it that it is having a 90 degree somewhere in itself there. So there is a 90 degree. So, and you can also show them that this one is the longest side, the shortest side, and this one is in between. And then you can later start naming them, the hypotenuse, the adjacent, and the opposite, and so on. And you teach them the different names of the different lines when you're drawing these things. And you can also teach them how to draw things like a circle, for example. You draw the circle and you tell them they must draw a circle, and make sure that their circle doesn't look like an egg or something, that their circle is nice and round as it's supposed to be. Now, properties of two-dimensional shapes is very critical that you teach them the properties, for example, of two-dimensional shapes. These shapes are flat and can only be drawn on paper. They have two dimensions, the length and the width. There is no third one. So it's either the length and the width. They are sometimes called plane shape. In other words, they are just flat like a plane. So those are the two-dimensional shapes. And you can show them examples like the one that you can see there, the red one, the purple one, the yellow, the blue, the brown, and the light purple. Those are the two-dimensional shapes that you can show them. Now, making posters to teach two-dimensional. It is very critical that as a teacher, you should make poster to teach this concept of two-dimensional. So, when you're making a poster, you need to show the example of the drawing. For example, you talk about a circle. Then on your poster, you must have a circle, and you name the circle. You give it a name and you say, this one is a circle. Now, and then you can give the properties of the circle. On the right-hand side, you can see there that there are properties. You can say, I have one side. My side is curved. I have no corners. That one is a circle. So sometimes you can also give them the properties and you ask them to draw the circle. So you tell them that please draw for me an object that have no sides, that have one side, that have curves and no corners, and that should be a circle. And then you go over to the square. I have 4 sides. My sides are all the same size. I have 4 corners, for example. That one is a square. And the other one is a triangle, for example. I have 3 sides. My sides are straight. I have 3 corners. So they must draw these 3 sides and there is no corner. There are 3 corners. 3 sides with 3 corners. And all the sides are equal. Now, if all the sides are equal, that means that this is a different type of a triangle. And then you can name that. And then you go to the rectangle. I have 4 sides. My opposite sides are equal. I have 4 corners. So then you see how it will differ from the square. The square, all the sides are equal. There are 4 sides. All the sides are equal or the same size. And there are 4 corners. But when you come to the rectangle, there are 4 sides. And the opposite sides are equal. And there are 4 corners. Now those are the type of things that you need to teach your learners so that they can be able to see the examples of the things that you are talking about. Now let's go over to properties of 3-dimensional. What is a 3-dimensional shapes? Now, 3-dimensional shapes have 3 sides. This is a cube height, length, and has 3 dimensions: the length, the height, and the depth. And all 3 shapes are solids. So when you look at that one, you can look at the sphere, or you can look at the prism, cuboid, cube, cylinder, pyramids, and cones. All these ones are 3-dimensional. Usually 3-dimensional shapes can stand on their own. You can put it there and it will stand. A 2-dimensional like this one, it can't stand on its own. If you put it there, it will fall down. But the 3-dimensional shapes usually can stand on its own. It's having 3 sides that can balance each other in terms of the standing. And it can stand on a flat area. That is the 3-dimensional shapes. And then we move over to the 3-dimensional shape in terms of explanations of properties. For example, we have a cylinder. A cylinder is a solid with 2 parallel circular bases. If you unwrap the middle section and lay it flat, it is a rectangle. That is a cylinder. What is a triangular prism? A prism with a triangular shape, only the bases are parallel. The base, when you look at the base, they are parallel, but then the others look like a triangular prism. In other words, there are 3 other sides: the length, the height, and the width. And then the same goes to the square. A square is a prism with 6 concurrent faces. All faces meet at 90 degrees angle. Opposite faces are parallel. It is a form of a rectangular prism. So, when we look at the prism, I want to explain the square. For example, when you are drawing the square, usually you draw a line like that. Let me use a red one because it's clear. when you are drawing a square, you draw a line like that, and then you can draw another line like this, and then you draw another line that goes up while this one is going straight up, and this is how you draw a prism. And this one they usually ask in the examination for you to draw. And this is how you draw it. Now, when you look at that, you must know that at the back side, the dotted lines represent that there is something at the back side there, but you can't see it. It's on the other side. And that is how you draw it. And then what they are saying there is that you have 6 congruent faces. When you count them, is 1, 2, 3, 4, 5, and 6 from the bottom. So those are the 6 sides that he's having. It's more like a dice, the one that we are playing with, and or they double with, and so on. So that one is the square. And all the angles here, they are 90 degrees. Usually when you are drawing 90 degrees, you show them with that these angles are 90 degrees to the surface there. And that is how you show it, that the thing is 90 degrees. Now, 3-dimensional shapes activities. For example, if you want to teach now the concept of 3-dimensional, what activities are you going to use? How will you teach these things? So the very first one is describing 3-dimensional shapes like cones, cube, rectangular prism, pyramids, sphere, cylinders, triangular prism, and you identify the different 3 shapes. In other words, you show the learners the different shapes, the 3 shapes. They must count. This is 1, and this is 2, and this is 3. This is the width, the breadth, the height, for example. And for 2-dimensional shapes, usually will only be 2, the breadth and the length. Now, have posters with various 3-dimensional shapes and request the learner to identify them. So you have a poster where you put various shapes. Some of the shapes can be 3-dimensional, 2-dimensional, flat surface, circles, and so on. And then you ask the learner, they must now tell you which ones are 3-dimensional. Then they must, for example, if you have them, the different shapes, and you have them as A, B, C, D, E, F, and so on, and then you tell the learners that they must now extract or write down only those ones that they think are 3-dimensional. Then the learners must write it on a worksheet, on a separate book, and so on. These are the 3-dimensional shapes, and so on. Bring various 3-dimensional and 2-dimensional shapes in a class and request learners to name and describe them. This is another activity. You can bring these various objects from home. For example, these ones are 2-dimensional, 3-dimensional, what, and then you tell the learners, please look at these shapes and tell me which ones are 2-dimensionals, which ones are 3-dimensionals, and so on. And then the learners must be able to identify or sort it out with their hands, pick up all the 3-dimensionals, put it in one box, 2-dimensional, put it in one box. In that way, you are going to help them to see or to connect the object to the name. And they can be able to look also into the properties, and you can tell them to explain the properties, and so on. And you can show them, for example, the previous slides where I show you that you can have the learners pick up an object, and they must describe that object. For example, I have 3 sides. They describe now, they make them, they own the object, or they make them as the object, and this, they are speaking on behalf of the object. These are games that you can play with in the classroom so that the learners can be able to say, for example, a learner pick up an object like this one, and then the learner will say, no, I am round, I am long, I am a prism, or whatever you call it, or I am a triangle, I am a what, after describing the various properties. And that is how you teach them how to remember or to connect the properties to the object. It's also one of the game. Learners should be able to sort 3-dimensional shape from 2-dimensional shapes. That is also another activity that you can have them. They sort out these things as we were just explaining. Now let's go over to lines and points. What is a line and what is a point? Points and lines are two of the most fundamental concepts in geometry, but they are also the most difficult to define. We can describe intuitively their characteristic, but there is no set definition for them. They, along with the plane, are the undefined terms of geometry. All other geometric definitions and concepts are built on the undefined ideas of a point and line. Now, we all know that, for example, when we come to a point, when you just make a dot like that, then you have a point. But what they are explaining here is that when you have a lot of points laying next to one another, they are laying next to one another, there are points after points after points, then you have what we call a line. So many points after one another becomes a line. That is the explanation that they are giving there. So points are just simple as that, but when they are many and they are laying next to one another, not that they are scattered around, but they are laying next to one another, then we talk about a line. So let's talk about in details what is a point. A point is an exact location in space. A point is denoted by a dot. Sometimes they say, make a dot or make a point. Put a point or put a dot. A point has no size. It just depends on what is the pen that you are using, or a pencil, how thick is it that you are using. A point has a capital letter. A point always has a capital letter. A point is a dot. A point is a dot in space. Those are the definitions for, as you are trying to explain to the learners, what is a point. Now, what will you explain? How will you explain a line? For the line segment, we specify a line with two endpoints. The starting with the corresponding line segment. We find other line segments that share at least 2 points with the original line segment. In this way, we extend the original line segment indefinitely. In other words, when you have to explain a line, you have to have 2 points. This is where the lines start, and this is where the lines end. So what you do is that you explain to the learner that they need to connect the 2 dots. As they are connecting the 2 dots, they are drawing a line. And this is how you explain the line. A line can be also from there up to there. So you can draw it in that way, or you can draw it from there to there, and you draw it in that way. So it doesn't matter how it lay. It can lay down, it can lay in this way, or it can be vertical, or it can be horizontal. It doesn't matter, but a line is when you are connecting the 2 points. But we must know that a line can also extend indefinitely. In other words, you can draw a line till forever. They don't have a starting and an ending, but you can draw as long as you can have the space to draw. You can draw it even around the world. Now, lines, as a student teacher, you should be able to teach learner to draw the following line segment. Very critical. You must be able to draw parallel lines, perpendicular lines, intercepting line, and you must be able to draw all type of angles, the 30 degrees, 45 degrees, 90 degrees, and 200 degrees. This you should be able to draw. Now, here I draw different type of lines that are bisecting each other or cutting each other at 90 degrees or less than 90 degrees. Some of them, for example, the middle one there, it shows A to B, and this line extends beyond the A and B. You can also talk about parallel lines. You can talk about lines that are perpendicular and so on. So, for example, if you are talking about, you ask your learner to draw parallel lines. If you have a line like that, that is my line, and then you are asking your learner, they must draw a parallel line to this one. When you draw a parallel line, it means that the other line must be here, and it must be the same distance. The distance between these two lines should be the same all the way. Those ones are called parallel lines because they will never cross each other. But if you have a line like this one, and another line comes there, you can see that these lines cross each other here. So they are not parallel. So if they are parallel, they never cross. If they are not parallel, they will one day cross. As you extend it, somewhere, somehow, they might cross each other. And then there's a line that is perpendicular. For example, if you have a line like that and this other line come perpendicular like that, meaning that it makes a 90-degree crossing there, crossing the other one at 90 degrees. This one is called a perpendicular line. This line is perpendicular. This line is perpendicular to this one because it's forming that 90-degree. And then we can continue to triangles, for example. A three-sided polygon, a flat shape with straight sides. The three angles always add up to 180 degrees. Students should know the properties of and ways to teach learner to understand the triangle. What is the properties of a triangle? Two equal sides and angles. In other words, if you have triangles that are having two equal sides and angles, and the angles are all equal, then that one is having a different definition or a name. There is a scalene triangle. For the scalene triangle, no sides are equal, no angles are equal. That one is called a scalene triangle. And the other one is called the isosceles triangle. So you need to know, what you need to know, especially in your study guide, there are different types of triangles that are explaining there, and they want you to master these names and the properties so that when you are going to transfer this content to the learners know exactly that what I'm dealing with here is a scalene triangle, what I'm dealing with here is isosceles triangle. So those are the few things that you need to know, especially when you talk in terms of triangles, so that you can be able to define these properties to the learners. Now, quadrilaterals. Quadrilaterals are four-sided polygons and four angles. There are many kinds of quadrilaterals that you need to know. The five most common types are the parallelogram, the rectangle, the square, the trapezium, and the rhombus. Now, I have given you some drawings there so that you can know how a quadrilateral looks like. So when you talk about a quadrilateral, there are, for example, those ones there in that side, they are all qualifying as quadrilateral. And the parallelograms are those ones, all those objects. Now, usually when you are talking about a parallelogram, one of the major properties of parallelogram is that there are two sides, for example, and these two sides usually are parallel to one another and equal. So if you have this one here, you will notice that these two sides are parallel, and these two sides are also parallel. In other words, this line, if you extend them here, they will never cross. If you extend this line here, they will never cross. And also, one of the properties of a parallelogram is that these two are also, as we say, parallel and equal. So this one is equal to this one. They are equal and parallel. So what we are supposed to do, okay, let me just draw another one to explain it better. If you have these two sides here, this is your parallelogram. Now you will notice that, as we say, these two sides here will be equal, and this one will be equal to that side. So this side is equal to that side, and this one is equal to that one. And you can also say that this side is parallel to this one, and this side is also parallel to this one. So in other words, they will never cross. That is one of the great properties of parallelogram, that you can distinguish between the others, for example, quadrilateral and so on. And then, for example, if you talk about trapezium, you will notice that there is two sides that are parallel, but the other sides doesn't need to be parallel. They can be longer or shorter, but sometimes they are parallel also. But one side, the two sides that are parallel are not equal distance. In other words, the length of those two sides are not equal. And then for the rectangle, one of the greatest properties of a rectangle is that the two opposite sides are parallel and equal, and the other two are also parallel and equal, but they are not laying on in funny ways or what, but they are meeting each other at a 90 degree. That is what distinguishes the rectangle from a parallelogram. Because at a parallelogram, they can meet at 90 or they can meet at any other degree. But at the rectangle, the angles are always meeting each other at 90 degrees. And the same with a square. The square, the greatest distinguishing characteristic of a square is that all sides are equal and all sides are meeting each other at 90 degrees Celsius. Not Celsius, 90 degree. And then also for the rhombus, it's the same story. So all sides are equal and all sides are parallel, but they don't necessarily meet at 90 degrees when you come to the rhombus. Now let's talk about circles. A circle is the locus of all points equidistant from a central point. What they mean with that is the following. When you look at a circle, any circle, you have a middle point there. Now, the other points are all around that point at equal distance. So in other words, the distance from here all the way to there must be equal to that one, must be equal to that one. Everyone here, the distance must be equal. In other words, all these points here, they are laying at equal distance to the center. Now, that one is a circle. Now, if you are teaching your learners to draw the circle, they must always have a center so that they can know that where is the center and how far is everything from the center. If your learner end up drawing a circle like this one, that is no more a circle, because when you have the center there, the distance here is longer than the distance there, then it becomes an oval form. It's not a circle. So always emphasize on from the center, the distance are equal to all the other sides. And that one is what we call a circle. So that one is not that really perfect, but when you're drawing it, you can draw it using the instruments so that it can be a nice round circle that the learners will be able to see. The following definitions are related to circles. Arc, a curved line that is part of a circumference of a circle. So an arc is something like this. So that one is an arc, not really a complete circle, but just a part of a circle. Those are the characteristic or definition when you talk about a circle. Then you have to talk about a chord, a line segment within a circle that touches 2 points on the circle. That one is called a chord. You will see the examples just now. So you need to make a difference between an arc and a chord. An arc is a curved line that is part of the circumference of the circle, while the chord is a line segment with a circle that touches 2 points on the circle. And then you need to know what is the circumference, the distance around the circle. In other words, when you are going to look at the circumference of this one here, the circumference will start from, for example, there, you start and you go around the circle. As you are going around the circle, that is the circumference of the circle. So if you put your compass there, it will go all around, and you will notice that one is the circumference of the circle. So that is one characteristic or property of a circle, is that it has a circumference. It has a diameter, the longest distance from one end of the circle to the other. So when we look at this circle here, the diameter could be from there through the center to the other side. In most important thing is that it must go through the center, from one side to the other side. That one is a diameter. This is what we call a diameter. So it stretches from one side to the other through the center. It must go through the center for it to become a diameter. That's the longest distance from one end of the circle to the other. What happened? So we say the diameter is the longest distance from one end of the circle to the other. Now the origin, the center of the circle is called the origin. Here, right in the center here, that's where we have the origin, in the center of the circle here. That's where the origin is. And then we have what we called a pi. A pi is 3.141592, equal to a circumference divided by the diameter of any circle. That is a pi. Now the pi is actually a number that they have arrived at that we can use to calculate any volume, or not volume, but any circumference. When you want to find the radius or the circumference, or what you use, the pi. And the pi is usually 3.141592 on your calculator. Now most calculators are having the pi. On your calculator, you will see it, it is there, and you can use it to calculate anything on a circle. And then we have the radius. Now the radius is the distance from the center of the circle to any point on the circle. So where is our radius on this one? When we look at this one, the radius will be from there all the way up to there. That distance there is called the radius. That distance there, from the center to any part of the circle. It can be from here to there, it can be from the center to there, it can be from the center to that side, but as long as it is from the center, is the radius. Now you will notice that when you have another radius here, then you have what we call the diameter. So the diameter is the long one, the radius is the short one, but they are all starting from or going through the center. Now a sector is like a slice of a pie, a circle wedge. In other words, if you want to look for a sector in this one, this part here, we can call it a sector of a circle. This part here that I highlighted here, it can be called a sector of a circle. This is from that radius there up to that radius is called a sector. So for example, if you are having a pie and you cut the pie in various sectors, then you can remove one piece and eat that one. That one, you eat a sector of a circle. Now the tangent of a circle is a line perpendicular to the radius that touches line one point on the circle. That's a tangent. Now a tangent is any line. When you look at this one, we can draw a tangent here. Now this line touches this radius or this diameter here at a 90 degree. That one is what we call now the tangent of the circle. So it's any line that touches the part of a circle, and then you can draw another line that is going 90 degree perpendicular to that one. That one is called the tangent. So here is our circle now. Let's look at the parts that we were just mentioning there earlier. So here you have the circumference, which is the area around the circle, and then we have the diameter, which is the area from one arrow straight through the center to the other side, one side of a circle straight to through the center to the other side of a circle. And then we have the radius, which is now the distance from the center of the circle to any side or touching any side of any arc of the circle. And then we have the arc. When you look there, the blue part there, that's it's an arc. And inside the arc, we have a section. In other words, you can remove that part. It's a section of the circle. And then you have the chord. The chord is that line that moves from one part, not going through the center to the other part of the circle. It's called the chord. And the segment is that part also. So there is a difference between a segment and a sector. A segment is usually inside the chord, and the sector is usually from the center all the way to the arc. So those are the differences that you need to know. And then when you look at the circle on the left-hand side, everything is the same. There we have a chord. So on the other side of the chord, we'll have a segment. And then we have a diameter and the center. And we have the arc, the yellow one there, and the tangent, which is now the red line there, which is touching the circle just. That one is called the tangent. So all this part of the circle, you need to explain it to your learner. So your learner must be able to understand these sections here. Now, in conclusion, at the end of this unit, please make sure that you are able to describe all these things and all these shapes, and be able to do activities with the learners, especially the three-dimensional shape, two-dimensional shape, terminologies of lines and points and those things. You need to master this thing. You must be able to explain how to measure and to clarify, to draw and notate angles and so on. So your learner must be able to practice this type of drawing, what they were just drawing now. Give them exercises where they can draw arcs. Give them exercises where they can draw tangents. Give them exercises where they can draw many other things that we just discussed. For example, the trapezium, the rectangle, the square, the circles, the cones, and all those things, so that they can practice and know how these things look like. And one of the best way also to do this is that you can bring examples of these things into the classroom and give the learners the examples, and they must take these examples and practice and do the activities and so on, so that they can be able to present or to understand and connect what they see physically to what they have learned. There must be that connection always, because if the learner have that connection, it actually helps him to understand. Learners like to visualize things. So as they are visualizing, it's the job of the teacher to help the learner to visualize and to connect objects to names, to characters, and so on. And then you must also teach them to describe triangles and recording of the length and the side and the size of the angles and so on. And then you must also help them to describe and clarify quadrilaterals that we were just discussing and so on. Now, students should use their daily teaching experiences we have discussed, and the other one, what you are doing in your classroom. You must be able to use that experience to answer questions in an examination or in an assignment. Try to use practical examples of things that you are doing in the classroom, because that will help us to know that you are connecting the theoretical knowledge that you know, that you learn from the book, that you learn from what we are discussing now, and you are putting it into practice in your classroom. That is the most important thing of being a teacher, is that you must connect theory to practice. Learners want to see things, want to see how you do that, how you explain that. They want to remember things, what they see. So you as a teacher, you should help them to see these things and understand these things visually by connecting what they see to what they know. Students should learn to connect the theoretical knowledge from the course to their practical experience at the classroom level. That is what we are talking about. Now, study in advance and learn to work in group as a study partner. Look for a study partner for things that you do not understand. Somebody you can call, somebody you can discuss the questions with. It can be in the same town or the town next to your town. Make a connection with these people and try to link up, meet on a certain day. For example, on a Saturday, you decide you are all coming to this place, to a classroom, you sit down, you discuss the assignment, you discuss various topics, you discuss the question paper, old question papers and stuff in terms of the examination, also things like examination presentations and so on. You discuss them and see whether you are also at the same level with one another, because you can learn a lot from another person. Things that you thought you knew, the other person might know it better and explain it to you. You must know that the more you explain things to others, the more you become an expert, even better than them that you are explaining to. So take time and explain things to your colleagues and to your friends that you are doing the same course, and you know that you are in the same year and so on. Discuss these things with them. Also, if you know there is you are third year or you are second year and there is somebody doing the first year, you can help these people, advise these people, in that you are just learning and you are doing yourself good. And then contact your tutor if you need clarification. And please, the contact is between 1700, which is 5 o'clock, and 2000, which is 8 o'clock. Don't call earlier than that. Don't call later than that. That's the time that you have to call your tutor. And that is the time, because that's the time that most of us, we are free by that time. And then you can contact us and we can discuss things. And please, when you are calling, call with a question that is, don't ask me a question that is in the assignment. Don't ask me a question that is, you want an answer now for the one that is in the assignment, because if I give you that answer, then it means you didn't do the assignment. I did it for you. So you need to ask how to do it. Don't ask what is the answer, or how do what question is, what is the question here, or maybe if you don't understand or you cannot see clearly or what, that's the time when you can ask for clarity and so on. Thank you very much.